Welcome to the Wasatch Mountains of northern Utah along Utah Highway 210 up here by the ski resorts Alta and Snowbird. And we have another edition of Random Road Cuts. So thanks for joining me on this little excursion. I'm Geology Professor Shawn Willsey. In this series, Random Road Cuts, we stop at a road cut, grab our rock hammer, and then try to put together the observations. We work together as a team to figure out what's going on with the rocks, come up with a plausible or likely geologic story based on our observations. So it's always good to start with what we know about the area. So here in the Wasatch in Little Cottonwood Canyon, there's a number of different rocks that pop out here. There's a sedimentary rocks up along the ridge here. Further down the canyon at the mouth of Little Cottonwood is granitic rocks, granites, intrusive rocks that used to be magma. And as you get up here by Alta, which used to be a mining town, there's more of the granite as we look up towards the Albion Basin area here, just to the east of Alta. There's more granite that pops out. And of course, it was this magma intruding these sedimentary rocks that created the metal deposits that attracted the miners here. So let's get started with this road cut, kind of a long one. We'll see if we can get through the whole thing. Looks like there's a little bit more diversity here on the east end. So we'll just get right to it. Luckily, there's a pretty good shoulder on the road. Not too many cars up here. It's a weekday, so it's not too crowded. So let's just start at this far end and see what we can see. Right away, I'm starting to see a little bit of layering in the rock. You see that these rocks have some layers, and there may even be a little bit of folding in here as well. The rocks are gray, somewhat kind of irregular. There's a lot of white and gray mixed in. And with the color and these white splotches, these veins cutting through the rock, and the fact that this rock is layered, and we'll do one more test just to see here how hard or soft this rock is. So notice my rock hammer pretty easily scratches this rock, so it's relatively soft. It's not made out of crystals, not seeing any crystals popping out of the rock. So this rock looks like it's a limestone, and one test we can do to make sure it's a limestone or carbonate is using our little acid bottle. That will test to see if it's nominally made out of carbonate. So we can go ahead and hit it with some acid. You can see a huge reaction there. So this rock is just 100% composed of calcite, and it's reacting to the acid, bubbling and fizzing as it releases CO2. So we've got a limestone here at the east end with some calcite veins cutting through it. We can just make out the layering, the bedding in it here. And then there's this brown face that's pretty sheer. And as we walk up to this, it's pretty planar. I mean, this whole surface is cut. It's cutting across the bedding. The bedding looks like it runs this way through the rock. You can see up towards the top of it here, it may be bending over a little bit here, so there may be a little bit of folding in the layering. So it's a big fracture surface, but it may also be just based on the size and how planar this is. It could also be a fault. Now, I'm not seeing any lines running across this plane. What we've learned are slicken lines that are definitive evidence for fault movement. Not seeing that, but it still could be a fault. But at any rate, it's a very sizable fracture. We can double check the rock type over here. Yeah, fizzing very strongly. So it's the same unit we were looking at here at the east end of the outcrop. So we've got some undisturbed limestone over here, some folded limestone that's a little bit browner, but I think that's just a product of weathering. And then this large fracture or fault plane here. And then as we start working our way to the west, I think I'm seeing, a little hard to see with the aspen shadows here, but more of the bedding possibly here, the layering in the rock. These rocks are definitely tilted, kind of busted up in this little section here. But right in here might be seeing more evidence of very steep bedding in the layers there. Still looks like the same rock, this gray rock here. We'll go ahead and test it just for kicks. Yep, sure enough, it's still limestone. It's the main unit we're seeing in the road cut so far. Here's a section, looks a little bit different. It's starting to show gray and white bands in it, and then there's these dark little layers in it that may be parallel to the beds as well. Let's go a little bit further. I think there's a better exposure. Yeah, right in here maybe. Let's see if we can work our way a little closer through the wildflowers. So it's changed from gray to white, which may be indicative, could just be a color change in the rock. But knowing that that granite lies not too far below, or possibly was adjacent to this rock, we have to consider that some of the rock has been altered by the presence, the heat, and the fluids that were associated when that magma body intruded these rocks. And so could be some, you know, weak contact metamorphism, or at least some fluidization of the rock here. Now this brown stuff in here to me looks a little bit different. This brown material in the rock looks like it could be something other than limestone. Let's see what we get with the acid bottle. So we're still getting a strong reaction here, but I bet if we put it right on the brown, notice there's no reaction when I put that on the brown. It's just fizzing along the margin. So over here in the light colored material, I get a strong reaction, but right here where the rock is brown, I don't get a strong reaction. And so these may actually be little lenses and layers of chert. Chert's actually pretty common in a lot of limestones. Of course, these limestones most likely formed in a marine setting when this area was underwater. So we've got limestone at the far right end that grades into possibly an altered limestone. I don't think I'd call it a marble just yet, because a marble would show more crystallization of the calcite, which I didn't really see, but maybe a little bit more chert in the limestone here on this end. You can see some of the banding again up in here, caused by the chert. And then also notice that the chert often, because it's harder than the calcite, it tends to stick out in relief. So as I touch this face here, these little brown layers actually stick out. I can feel them protrude from the rock face because they are more resistant than the limestone itself. One more fun little test here, just to kind of show you. So again, there's the limestone, but if we can find a bigger blotch of the brown material, notice we don't get much of a reaction. It's just when it kind of goes off the brown and into the adjacent material there that it fizzes. So some limestone units here. And then there's a pretty pronounced color and textural change. Let me back up and try to get this all in. Right about here, these rocks to the right are the same rocks we've been looking at, light gray to almost white with some tan staining on it. But everything to the left is a little bit different color. And so we may have right here, running through this inaccessible sort of crack, we may have a fault. If not a fault, a contact between two different units. Again, can't say for sure what the nature of that contact is, whether it's a fault contact or if it's something more typical of just trying to get up the hill. Sorry. I think I see, maybe not. Maybe a little hint of metallic minerals in here. They're probably a little too small to see on the camera, but do you see some sparklies in this little zone in here? Need to probably get my hand lens on those. Could be some metal mineralization in this rock. But let's figure out what this unit where this rock type is, starting with some observations. You can see different color, more brown, yellow. Doesn't appear to have any layering now, but that may change. It's pretty fractured and busted up. Some of the color may be due to weathering, and or these rocks look like they've had fluids move through them. They look like they've been kind of altered by hydrothermal fluids. Again, seeing some little sparkly minerals in there. Let's see if it fizzes, and we'd like to get a nice fresh sample or surface for that. So there's a nice little fresh exposed surface, and let's see if we get any sort of reaction. Not really no reaction whatsoever. So we definitely have a different rock type than what we were seeing before. The rock here is very fine grained. The little kind of metallic minerals I was seeing was kind of on fractured surfaces. I didn't really see them in the rock. The grain size again is very fine. Could be a metamorphic rock, could be a very altered sedimentary rock like a shale or a mudstone. But let's keep looking and see what we find here. Might be some hints here of layering, bedding, kind of dipping away from us here. But this is why you spend more than just a few minutes and don't jump to conclusions. And then right here at road level, there's this big fracture, very planar surface. I mean, this thing, if I can get it from the side, this thing is just beautifully planar, a little bit overhanging. And again, just like the one we saw at the upper east end of the outcrop, this may be another fault. At a minimum, it's a very large fracture, but it may also be a fault. Again, not seeing any definitive slick insides running across the face of it or anything like that. Okay, now I think I'm seeing a little bit better that this has some pyrite in it, or at least what I think might be pyrite. I have to get my hand lens out here in a little bit, but there's some definite little gold metallic sparkles. It's not in the rock, it's just coating these faces that are weathered, and hopefully you guys can see that as well, this kind of goldish sparkly material there. Here I might be seeing a little bit more of the bed. You can actually see a little bit of a fold right here, which does more or less run the same direction as the beds I was seeing over here. So we may be starting to see the hint of some sort of layering, likely bedding, possibly foliation that runs through the rock. So a lot more of the same here. That fracture or fault comes down to about here. It's a little pocket of light colored rock up here above the bush, but looks like it's a little hard to get to given how steep this is. And then we get to a section of rock where the layering, probably bedding, is a little more obvious. Again, this is another very smooth surface here. Again, could just be a big, well-developed fracture, but could also be a fault. The rock does look a little different than what we encountered over the last few feet. The color's a little different. It's definitely not the limestone though. It's a little too hard and brittle, but we'll give it a quick little test here. At least I don't think it's the limestone. Again, shouldn't jump to any conclusions. Yeah, no reaction to the acid there. But definitely well layered. You can see everything's dipping in this case down to the left, which is to the west at about a maybe 40-50 degree angle. A little bit of a shattered zone in here. These rocks have really been busted up. I mean, these rocks, it's pretty apparent these rocks have seen some pretty dramatic histories. Now here's something interesting. It looks like there's maybe a couple different orientations of the beds running through here. So the stuff down low is somewhat steeper, and then once you get to this point here, this stuff is running at a different angle. So we have this material running at maybe like a 65 degree angle to the west, and then there's a sharp line here which may be a fault, and then the material above it that's dipping to the west but at a shallower angle. Steep dips here that may be actually bending a little bit as I look at those. Yeah, so sometimes, you know, you got to kind of toggle between standing really close to look at things and then moving back to get a bit more of a cohesive picture. Yeah, these rocks are just kind of chaotic. I mean, the bedding in here is just really kind of all over the place, and it looks like right here, let's see if I can get that in for you, is a nice fold. You see that come around and then back out, so it's like a Z fold. It represents, or similar to the letter Z, so it comes down, bends, and comes back. Are you seeing that like I am? Hopefully. You never know how things look on camera and video versus being here in real life. Here's maybe a better example, although this may actually be a fault. You can see there's a little crack that runs through there, and it doesn't look like the beds are continuous. That may actually be a fault that's offsetting this lower section and this upper section. Yeah, really beat up and deformed rocks through here. What else do we have? More fractures. Fractures here are a little stained with white, so there's a little bit of mineralization. The beds really show up here, again, west dipping or to your left at about maybe 40 degrees or so. More of the same. And then let's go down a little bit farther. It's a big outcrop in Roadcut, and I don't want to take the time to run through the whole thing because I'm only maybe halfway through it even as we speak. Gosh, you can see some of the folding just by looking at these swirls. Do you see some of these just incredible patterns and textures running through the rock? It helps that these rocks are not only layered, but that the layers are very fine and close together, because that really helps us pick out and see some of the folding in here. So it looks like there could be one right here. This red face, bit of a fold there. More of the layering. Huh. Some interesting stuff going on here. Some of these fractures. And just a little bit further here. Yeah, more folding up here. Again, it's fairly obvious to me, but depending on how the camera picks it up and how well I can kind of show you. So just these small internal folds, while the bedding mainly, for the most part, dips to the west. But you can see up here it's dipping to the left or to the west. But as I come down to the bottom of the outcrop, it's actually dipping in the opposite direction. So again, maybe another structure, a fault or something in there that divides those two packages of rocks. Oh, and here's a pretty nice set of folds here. I think you can pick that one out. It starts up here, comes over, comes around like that. That's beautiful. Sexy, sexy stuff here, team. Good, deformed, folded rocks. Pretty sweet. Well, that's probably long enough. It's been about 20 minutes so far, so hopefully you've enjoyed this fun little road cut here in what looks like to me a pretty deformed section of rocks adjacent to probably the intrusion of magma that's in Little Cottonwood Canyon. Possibly also these rocks have been impacted by older deformational events like the severe orogeny. So there's a number of things that could be responsible for the folding, the alteration, the deformation that we've seen here. But we started at one end of the outcrop with pretty healthy looking limestones. They got a little bit more altered. Then there was a big contact or change to these other rocks that were not limestones. These, I guess I'd call them shales, mudstones. They might be low-grade metamorphic rocks. And then that kind of continued down the way, and they showed quite a bit of deformation. So we'll go ahead and sign off from this fun edition of Random Roadcuts here in the Wasatch of northern Utah. Thanks for your time, your support, and we'll see you at the next road cut.